Good afternoon. Welcome back to my channel. Today I am going to explain about the topics in computer organization and architecture related to instruction cycle execution or instruction execution cycle. We are all familiar that any instruction that has to be executed, it has to go through a cycle, and that cycle is repeated for each and every instruction associated with a particular program. So there are prominent phases that any instruction cycle has to go through. First phase is we have to fetch an instruction from memory. Once the instruction is fetched, then we have to decode the instruction. And then the effective address for that instruction, if at all it is having any indirect address, it has to be calculated. And the last stage will be executing the instruction. So fetch, decode, calculate the effective address, and execution of the instruction. These are the four main phases that occur in the execution of an instruction for any program. And these steps are repeated for each and every instruction in a program until we reach the last statement. So whenever we are trying to work with the instruction cycle, there are a familiar set of registers out of all the available other general purpose and special purpose registers. So the prominently used registers here are, we have a memory address register. So this memory address register, it is connected to the address lines of the system bus, and the address, okay, of the memory word which has to be read or which has to be written into will be specified through this address register. The other register is memory buffer register. So here in this memory buffer register, it is the one which is connected to the data lines of the system bus. Hence, whatever data is to be fetched, okay, based on the last read operation, that data will be residing inside the memory buffer register. Another important register is program counter. So this program counter, it holds the address of the next instruction which has to be fetched. Then the instruction that is fetched will be stored in the instruction register. So in short, the instruction register, it holds the currently executing instruction or the lastly fetched instruction. And any instruction cycle is also known as fetch, decode, and execute cycle. So this is an alias for an instruction cycle, where instruction cycle is also known as fetch, decode, and execute cycle. Now, to understand the sequence of operations which are carried out during the fetch and decode phase, we try to perform the operations during various timing signals. So here we have taken T0, T1, T2, so on as different timing signals. So initially, the program counter address is loaded into the address register. That is, program counter will be initialized with the address of the first instruction. That is loaded into the address register because it is the only register which is connected to the bus directly. Hence, the address of PC has to be loaded into AR. Now, during the fetch phase. During this time T1, that is during the next transition, clock transition, the memory word which is present at this address register is fetched into instruction register. So the currently executing instruction will be brought into the instruction register. At the same time, your program counter will be incremented so that it can point to the next instruction that has to be executed. Once our instruction is readily available, then we have to go with the decode operation that is taking place during the timing signal T2. So decoding is trying to identify the type of operation that can be performed on the instruction. So represented as D0, D1, so on up to D7. So total 8 decode symbols are used to decode the instruction, and our 16-bit instruction is decoded by considering the most significant bits, that is from 12th bit to 14th bit. And your address register is holding the 0 to 11 bits, which represents the address of the instruction. And if there is an indirect address, then that indirect bit, that is a 16th bit, 0 to 15 is nothing but 16th bit, is stored into the I, which represents a mode bit, where mode bit is 0 for direct address and it is 1 for indirect address. Now, once our instruction is available to be decoded, then it is necessary for us to categorize the type of the instruction, whether it is an input output instruction, whether it is a register reference instruction, or whether it is a memory based instruction. So we can better understand that by looking at this flow chart, where the sequence counter is initially set to 0. Let me minimize. Yeah, so the sequence counter is initially set to 0 here, and then whatever operations we have seen for fetching the address, for fetching the instruction at that particular address and decoding the instruction, those sequence of operations are represented by a rectangular bar under the timing signals T0, T1 and T2. Now, whenever we are trying to decode the instruction, if the value of D7 bit, the D7 value is 0, then we represent that it is a memory reference instruction. So D7 0 means it takes the values from 0000 to 6, that is 110. And if D7 is 1, that means if it takes the value 111, then the instruction can be classified as either register reference instruction or input output instruction. Now, if the D7 bit is 1, that is it is having from 12 to 14th bit of your instruction, if they contain 111, then you can categorize the instruction as either input output instruction or a register reference instruction. Now, in order to differentiate in between them, we have the 15th bit, which is representing I. Here, the I does not indicate the mode bit, but it is just representing a value as 0 or 1. If I is equal to 0, then we decode the instruction to be a register reference instruction and we execute that instruction, setting the sequence counter to 0 so that we can go ahead with fetching the next instruction in the sequence. If at all the D7 is 1, and I value is 1, then in that case we categorize the instruction to be an input output instruction. So we execute that input output instruction, check for setting up the required flags, and then reset the sequence counter to 0. We repeat this procedure for another set of instruction which is to be executed. Now suppose if D7 value is 0, that means the 12 to 14th bit of our instruction does not contain 111, but rather they contain a combination of numbers starting from 000 to 110, which represents the decimal 0 to decimal 6. So in that case, our instruction is categorized to be a memory reference instruction. Now, when in our instruction is a memory reference instruction, then in that case, we have to check for a bit known as mode bit. So here, this I bit is known as a mode bit. So this mode bit, it can be 0. If there is a direct address, means directly the instruction is available. The operand can be fetched from memory. So we directly execute the instruction and reset the sequence counter to 0, thereby setting the trying to proceed with the execution of another instruction. But if the instruction is having an indirect address in the sense the operand is not directly available in memory, but in fact the operand is represented by an address which is in turn an address of another instruction in memory. So in that case, we have to fetch the memory word at that particular address and now update the address register with that particular memory word, and we try to execute the memory reference instruction and then set the sequence counter to 0. So this is the process which we repeat for each and every instruction in a program that has to be executed. So to summarize, the instruction cycle is a cycle which is followed by any instruction that has to be executed in a programming language or in a program. So if a program contains a sequence of instructions, then every instruction has to go through the following 4 phases. That is, fetch the instruction, decode the instruction, calculate the effective address, and then execute the instruction. To execute the instruction, we try to focus on the decoded bit D7. If D7 bit is 0, then we categorize the instruction as a memory reference instruction, which can take the values from 000 to 110. Again, in memory reference instruction, we check for the mode bit to check whether the instruction is having a direct address or indirect address. If it is having a direct address, we execute the instruction by fetching the operand. If it is having indirect address, then we need to refer to the address and update the address register, and then we fetch the instruction. If at all the D7 bit is 1, then we categorize the instruction to be as either register reference or input output instruction. If the I bit, that is the 15th bit, is 0, then we categorize the instruction as a register reference instruction. And if I bit is 1, in that case we categorize the instruction as an input output instruction. This process is repeated for each and every instruction in an instruction cycle. Hence, this cycle is also known as fetch, decode and execute cycle. Thank you for watching. Please like, subscribe my channel. Thank you.